Okay, today in IM2 we're going to discuss dilations. This is Unit 8.1. So a dilation is a transformation. Now, we've talked about a lot of different transformations. We have done vertical translations, we've done horizontal translations, we've done rotations, and we've done reflections, where we've just reflected it over a line. Okay, so we've done all of those, and we've also done vertical stretches and vertical shrinks. These are different. So a dilation is a transformation in which a figure is enlarged or reduced with respect to a fixed point C, called the center of dilation. And there's a scale factor involved, which we're going to call K. So the scale factor is a ratio of the lengths of the corresponding sides of the image and the pre-image. So what they mean is the new to the old. And this is very specific in dilations. So if you look at this, you need to understand which part is the new and which part's the old. So when you see a letter with a prime on it, that tells you that is the new image. Okay, the P prime, Q prime, R prime is the new image. And they call that the new. So that's the new picture, that is the image. The pre-image is the original. Okay, or the other word for it is the old, which is what I used over here. Okay, so when we're looking at that and we want to set up the K, we have to do it that way. Now, when they figure out the K in this picture, they're going to say CP prime to CP, and that's how they would figure out the K. Okay, sometimes they'll give you numbers and values, but that's different. Okay, so that's not what they're doing here. So notice that the picture maintains the shape. All the angles are the same. These are real important things to understand about dilations. If you look over here at the bunny, you can see that the bunny's just bigger, but everything else about it is the same. So this one is an enlargement because it's getting bigger. And this one also is an enlargement because the real image, the original image, got bigger. So how do we know by looking at K what it is? So when the scale factor K is greater than 1, then the dilation is an enlargement. When K is between 0 and 1, a fraction, a positive fraction, a dilation is a reduction. Okay, so looking at this picture, what is the center of dilation? We can see that it's Z. Which rectangle is the pre-image? Okay, so we're going to look. This one has primes. This one does not. So therefore, LMNP is our pre-image. Okay, and we could also say the original image. Okay, that's where we started. Then LMNP, L prime, M prime, P, N prime, P prime is our image, which is our new one. So if I was going to calculate the scale factor, it would be ZP prime, same one, that's still the new over the old, okay, don't forget, and then ZP, okay, so I can pick any point, but I have to use the same, letter. So I could do ZL prime to ZL, and any of those would work. Now, looking at this picture, is this an enlargement or a reduction? Well, look at the size of your original picture and look at the size of your image. So this is a reduction. Okay, so we have a couple of examples here. Now, in this case, they're giving you values here for your sides, so you have to be very careful and look at everything. So I put the hint here. We're going to find the scale factor, so we're going to find K, and then we're going to tell whether it's a reduction or an enlargement. So first thing I'm going to do is look at my new. My new measurement, CP, is 12. My original picture is P, so CP is 8. So I can reduce that to 3 over 2, and that is greater than 1, so that's an enlargement. Okay, go over to this picture. Here's my prime, and it shows me that this part is 18. So if I want to write it out, I can. So that would be 18 over 30, and again, this is my k, and that reduces to 3/5, and therefore this is a reduction. All right. So here are, oh, and don't forget, you can write these as a fraction, a decimal, or a percent. It might depend upon the problem. I'm usually okay with you leaving it in just simplified fraction form. Okay, so this is in your journal, extra practice numbers 1 through 3 on page 252. If I was you, I would push pause and give these a try to make sure that you understand them yourself. When you're done, then turn it on again and we'll go over the problems. Okay, so remember we want to do new to old, which means we're going to go CP prime to CP. Notice that they don't give us a distance here, but they do give us this distance. And since the complete distance is 4, we can just subtract 2, and that will tell us that this one is also 2. And then we do 2 over 4, which is 1/2, and this is a reduction. Okay? All right, for this one, remember, look for your prime first. Get yourself ready. So this would be C prime equals 25 to CP equals 20. So this one is going to be 5 over 4, and this is an enlargement. Okay? Look carefully at this one. Here's my center of dilation, and I'm going out. This is my original picture. This is my new picture. So CP prime is 27, and CP is 3. So that equals 3, which tells me that this is an enlargement as well. Okay? All righty. Okay, so now we've got, this is important to note, in this chapter for all of the dilations in the coordinate plane, the center of dilation is the origin, so right there, unless otherwise noted. Okay, so the coordinate rule for dilations. So if P xy, so that's point xy, is the preimage, so this is my old one, then its image after dilation, with the origin being the center, is the scale factor. So we find a scale factor, and all we have to do is multiply it by our x and by our y, and that gives us the new image, the P prime. So it's kind of cool. It's not difficult at all. Okay, so here's an example of dilating a figure in the coordinate plane. So they give you the preimage, and they want the image after a dilation with a scale factor of 2. So you've got a picture on the coordinate plane, and you've got to regraph it. Rather than regraph it, just remember that all you have to do is say my original xy is going to become 2x, 2y. I just multiply each x and each y by a scale factor of 2. So here's what it would look like. This is an enlargement because 2 is greater than 1. And we just take 2, multiply it by 2, take 1, multiply it by 1. So rather than trying to draw this, you would just multiply each of the coordinates, get the new coordinates, and then graph it. Let's see what that would look like with a reduction. So we've got this is a quadrilateral, and it's got these points, okay? And it has a scale factor of 1/3. So you can see they were really nice and made everything divisible by 3. So when you put that into this is your transformation, so make sure you write that down. So my original xy gets multiplied by 1/3 times each, by both x and y. So each pre-image becomes the new image. And you graph those pictures, and then the enlargement just shows up. You connect your vertices. Okay? So in this case, you look at this one, and you can see that M and M prime lie on the same point. Okay, same with L, lies on the same, and it just goes like that. Okay? So always know that your points and the preimage and the image will always be on the same line with the center of dilation. Okay, so if you look at this picture, what I want you to do here is find K. So how do you think you're going to do that? Stop and think about that. Okay, so the first thing I figure out is that I've got a point J here. Okay, J is 7, 3. Then I look at J prime, which is my new image, and I figure out that it is 14, 6. Then I can look at this. My original XY was 7, 3, and it's going to 14, 6, and I can see that I multiplied both of them by 2, and that gives me a K of 2. Okay, now would that work with every point? Let's check H. So H is 3, 7, and then H prime then should be 6, 14. So let's look. Go up 6, 14, and there it is. Okay. Okay, on this sheet in your journal on page 252, you're going to be giving the new points and then graphing the image next to the pre-image on the page. So I would push pause here. Don't forget you want to find your new points first, but go ahead and push pause and then we'll come back. Okay, so I have A, negative 3, 1, and I want to change that to A prime. And I do that by multiplying X and Y by 2. So I get negative 6, 2. Then I do B is negative 4, negative 1. That goes to B prime. So that'd be negative 8, negative 2. And C is negative 2, negative 1. Multiply by 2. And I get negative 4, negative 2. So let's check out our picture and see how we did. So look at A. A should be negative 6, negative 2. There it is. B is negative 8, negative 2. There it is. And C is negative 4, negative 2. And there it is. Okay, so let's try this one. P, the original P is negative 10, 0. I'm going to reduce it because this is 1/5, less than 1, by 1/5. So it's going to be negative 2, 0. Remember, 0 times anything is 0. Okay, Q is negative 5, 0. So that becomes negative 1, 0. This is a quadrilateral, so R is 0, 5. That becomes 0, 1. And S is negative 5, 5. And that becomes negative 1, 1. So let's see how we did with our picture. Okay, so our new, this should be P prime, Q prime, R prime, and S prime. So S prime, this is our image, remember, this is our pre-image. So, pre-image, that's our original picture. So we should be looking at a much smaller picture because it's a reduction of 1/5. So sure enough, P is right here. It's negative 2, 0. Q is negative 1, 0. R is 0, 1. And S is negative 1, negative 1. Or negative 1, positive 1. So we're good to go. And the nice thing is if your picture doesn't look like this, then you just go and check the math that you did for that specific point. Okay, so this is constructing a dilation. This is just an FYI. So you can look at this and see how you would do it. You would get a point of a center of dilation. You just choose one, and then you just draw lines from the center of dilation through each of the vertices. And then you could just pick a point. This has to be the same distance, though, on each one. And you'd pick a point, and that would create your triangle P prime, Q prime, R prime. Now notice that when they pick this point, since you're constructing it, they're going to make an arc here. And then they're going to go from Q and make the same arc, and then they're going to go from R and make the arc. So they're making this distance the same for each of these. And then you connect them, like I showed. Okay, in the coordinate plane, you can have scale factors that are negative numbers. When this occurs, the figure rotates 180 degrees, okay, 2 quadrants over. So when k is greater than 0, a dilation with a scale factor of negative k is the same as the composition, meaning the combination of a dilation with a scale factor k followed by a rotation of 180. So two things are happening about the center of dilation. That's key, okay? So using the coordinate notations, rather than trying to figure out how to draw this and how to rotate it, you can just use this. So you do the original dilation, multiplying both k and x, multiplying both x and y by your scale factor, and then you go one step further and multiply both of them by a negative, and that will rotate it around. Then you can just regraph using the new points rather than trying to draw it yourself. Okay, so this time we're going to use the negative scale factor ourselves, and they want us to graph the image and the pre-image. But rather than do the graphing first, I'm going to calculate and use my new coordinates. So I'm going to write down my first coordinate, okay? Then I'm going to use the scale factor, and I'm going to say negative 1/2 times negative 4, comma, and negative 1/2 times negative 2, and that's going to give me the point positive 2 and positive 1. Okay, then I look at G, and that is my new F prime. Okay, so I look at G, and G is negative 2, 4, and multiplied negative 2 times negative 1/2 is positive 1. 4 times negative 1/2 is negative 2. You're doing fractions and negatives, so be very careful. That is my G prime. Okay, then I have H, and H is negative 2, and I multiply negative 2 times negative 1/2, and that's going to give me 1. So those are both 1, and that's my H prime. Now, when we graph it, so we're just going to go ahead and graph these 3 points together and graph these 3 points together, and we'll have both our pre-image and our image. We know that it's a reduction and a rotation, so we have to be careful, and that's what our new picture will look like. Now, I want you to notice that each of these points rotated two quadrants, okay? 180 degrees is 2 quadrants. This could be clockwise or counterclockwise. We learned that when we did rotations in IM1. We learned that 180 degrees ends up in the same spot, whichever direction you go, okay? And then H went 2 quadrants, so this is 1 quadrant, 2 quadrants, and F went 1 quadrant, 2 quadrants, okay? So G just moved a lot farther because it's higher off the axes. And remember, the center of dilation is always 0, 0 in this book, okay? Okay, so here's a logical scale factor problem, and you are making your own photo stickers. So the original photo is 4 by 4, that's this one, and you want to make these little itty bitty stickers which are 1 by 1. So when they're asking you what is the scale factor, think about what you need to remember. Remember that K is the new over the old. Okay, so that means it's going to be the new image is 1.1 and the old image is 4. That's the length of one side. So you can set up that ratio. So there's the scale factor. Now, when you're doing scale factor, an important thing to remember, and with any time you're using fractions, is you do not leave decimals in a fraction. So this is how they describe it, and that is what your scale factor is. So it's 11 to 40. Okay? Alrighty. Okay, so again, I would push pause if you want to work this out. So you're going to take each of these points and you're going to multiply it by the K. Now in my case, I would probably multiply by 1/4. I think that would be easier. So take a second, push pause, see if you can get these numbers, and then I'll put them up and you can see how you did. Okay, so these are the new numbers. So notice that -8 times 1/4, it's -1/4, sorry about that, So the negatives cancel, and it's 2. Okay, you pick this one. 20 times negative 1/4 would equal negative 5. So each one of those points needs to be multiplied by negative 1/4. And don't forget that 0 times any number is still 0. Okay? Now, we have a biology book shows the image of an insect that is 10 times its actual size. So the image is the new image, right? And the 10 times is our scale factor. The image, the new picture, is 8 centimeters long. What is the actual length of the insect? So how big is it really? So the first thing we're going to do is we're going to set up our ratio, which is 10 to 1. Okay, then we're going to set that equal to our scale factor, which is 8 to what we don't know. Remember, this is 10 to 1. It's our image to our pre-image. And we're using our scale factor to be able to figure that out. That our image is carried, same thing, you have to have the image on top here. And then we have our pre-image, which we don't know what it is. The pre-image is the actual size of the bug. Then we're going to cross multiply. We get 10x equals 8. So x equals 8 over 10, which is 0.8 centimeters. So which is big enough for me. Okay, the last little bit of information I want to give you is just FYI. So it says, when a transformation such as a dilation changes the shape or size of a figure, the transformation is considered non-rigid. When we move translations, when we move them over, they're exactly the same size and shape. But a dilation is non-rigid because we're changing the shape. Okay, we're expanding the shape. Any kind of change is non-rigid. So we've already learned about some of these when we did horizontal stretches and shrinks. But pay close attention to what information is changing here. When you're doing a horizontal stretch, you are changing angles, okay, which we did not change with a dilation, but we're also changing sides, okay? So be careful with that. So these are not dilations. These are stretches and shrinks. They are transformations, and they are non-rigid because the size or shape changes. Okay, and these are also non-rigid. Okay, so that's all for today.